Hey guys, it's Miss Peyton. I want to talk to you about additive and multiplicative relationships today. So the thing about additive and multiplicative relationships, we know that they're placed or defined in the format either y equals x plus a or y equals a plus x, a being the constant in the equation. But then when we turn into a table, it can be very confusing. So the whole thing with, when you learn in 4th or 5th grade, input-output, really correlates with this. And the whole thing with additive and multiplicative relationships that you should be asking yourself is, what's happening to x to become y, right? So over here I have an x and y input-output table. But if I say for every x, 1, right, 2, 3, and 4, and then here I say that this is 4, this is 5, this is 6, and this is 7, then I need to find the rule, and that's what it was called before, right? But what it actually needs to be is the formula, right? What's happening for x to become y, right? That's what we have to think. And so every time x goes into y, there's something happening, right? And you can see it. We're adding 3, right? We're adding 3, we're adding 3. And so that means we have for every x, you add 3 and it equals y. Okay, so this is the equation that represents what's happening here. This is the formula or the rule. And then we're going to switch it because as you get into higher grades, it's usually y equals, that's a proper mathematical formula. So this is going to represent y equals x plus 3. And then there's a wonderful thing about additive relationships. You always start at the origin, but it doesn't go through the origin, right? If you were to plug in each value for x, it would give you an output. And these actually become a coordinate. So this would be 1, 4, this would be 2, 5, and this would be 3, 6, and this would be 4, 7, right? Once you plot it, it's going to give you that perfect formula for even the graph, right? Take to that next level with that multiple representation. So here, when we have multiplicative, if I have 1, 2, 3, 4, and then I have 4, 8, 12, 16, and I ask myself, what is happening to x to become y, right? I can kind of look and see that, okay, what is happening to x to become y? Okay, well, it's either adding 3 or timesing by 4, if I'm not sure. Even if I'm stating it here as multiplicative, I still need to figure it out. So here I'm adding 6, but I'm multiplying by 4. So I have some consistency, so instantly I know I'm not adding, I'm multiplying. And then I keep going because there's a rule. 3 must agree. 3 rows must agree for us to make it a rule or a formula. So we have times 4, which is 12, and then 4 times 4, which is 16. So again, now I've figured out the pattern, right? I broke the case. So x is multiplying with 4 times x to equal y. This is not the proper mathematical format, right? We know that 4 times x combines to 4x, and we know that it should be in y equals format. So the formula or the recipe for this table is y equals 4x. Now we take it one step farther because this can be graphed. And again, this 2 becomes an ordered pair. Now the easy thing about multiplicative